So scientific notation exists so that mathematicians, scientists, and other people don't have to write really, really big or really, really small numbers over and over again, because it would be a lot of digits to write. And so they've come up with this thing called scientific notation that allows really large or really small numbers to be written in a simpler way that's a lot less digits to be writing. So basically, scientific notation is combined of two things. You've got a number that is between 1 and 10. Be careful with that. It can't be 10. So it has to be from 1 to like 9.999. And then you have this power of 10. And what you have to do when you look at a number is decide those two things. What number am I going to use that's between 1 and 10? And what's my power of 10 going to be? The power of 10 is essentially just how many decimal places that you moved. So for example, with this number 93 million, when I look at the number 93 million, what do you think you could do to have a number between 1 and 10? Well, hopefully the thing that makes the most sense to you is to realize that we would write 9.3. That's a number that best represents 93 million, but is between 1 and 10. Then the next question is turning that into a power of 10. So we're going to multiply that by 10 to the exponent of something. This is where you need to be careful. Some people just write how many zeros there are, but it's not the number of zeros. It's how many decimal places you had to move to get the number 9.3. So you had to move 1, 2, 3, 4, 5, 6, 7 decimal places. So it will be times 10 to the 7. So be really careful with that. So let's just do some more examples. So when we look at this one, the number between 1 and 10 that we're going to use will be 1.23 times 10 to, and again we check how many decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be times 10 to the 9. This next one will be 1.42 times 10 to the 1, 2, 3, 4, 5, 6, 7. Now, writing it in standard form is the exact opposite. It's moving the decimal however many times is in the exponent with the 10. So if there's 7 in the exponent, that means we need to move the decimal 7 times. So we go 1, 2, 3, 4, 5, 6, 7. One thing you're going to notice is if this one took me 1, but I had to move 7, so that means I'm going to end up with 6 zeros. So that's something to think about, is I moved 1 place plus I had to go 7 in total, so 1 place plus 6 more equals 7, which means I'm going to have 6 zeros. So using that strategy, I had to move 2 places, and then I need to get to 6, so 2 places plus 4 more makes 6. That means I'm going to have 4 zeros. So again, this is not how many zeros you put, it's how many decimal places. If that was confusing, then just go 1, 2, 3, 4, 5, 6, and just fill in the missing zeros. That's all you have to do. So there's lots of different ways that you can do it. It doesn't matter how you do it. It matters what makes the most sense to you.